Hello, today we look at automation of Stable Diffusion via PowerShell, creating hopefully a lot of nice crystals in my case, but the whole thing is steered via a JSON file, so you can actually create what you want. So we will install Stable Diffusion. If we don't already have it, then we use a PowerShell script from GitHub to start creating as much as we need. And the outcome should be a lot of nice crystals or whatever you actually want to create with that. I will show how to exchange the model from CivitAI and how to use LoRa's to put a bit more details in it. And yeah, let's start. First thing first, we need here a couple of scripts from my GitHub. This is the Stable Diffusion automation. You see a couple of hints how to install Stable Diffusion, for example, what the scripts are all about, but we will show that also here in the video. I'll have to put the URL in there later. We need PowerShell. It should be there with Windows. If you don't have it, you just do winget install PowerShell, Microsoft.PowerShell, and then it should be no problem. What we definitely need is the Stable Diffusion web UI. You get it here from this GitHub address. And important to install that, if you don't already have it, you need a graphic card, a dedicated one from NVIDIA or AMD. NVIDIA is better actually, and otherwise it will take forever. What you also need is Python and Git. Both you can install via winget, for example. Winget install Python, winget install Git. That is easy to do. And then you all just have to download it and we will have a look at it, how it works. And then you can happily start creating images locally. So we grab this URL here, right click, I use TortoiseGit, and we clone this repository. That's a fast one, it's got just a couple of scripts. And then here with the Stable Diffusion web UI, same thing, right click, and clone that one. That is much larger. And we actually have to build it first. So given that you have installed Git, NVIDIA drivers, and your Python, then you just launch this web UI.bat, and that will take actually longer than here. I speed it up a bit, so 10 minutes or so to build the whole environment, to compile everything that is needed, and then it should launch after a couple of minutes. It should launch the local Stable Diffusion UI, where you can already start creating things, but we want to fine grain that, of course. So let's create an apple and let's look what kind of models are there. It comes with installation, a short one. So here's our first apple. Not what I thought, but okay, it's one. And now let's have a look what we can do here. First thing, we need to exchange the model. CivitAI is your source for models. That is quite easy to use, really. So we use here the Juggernaut XL, had for me the best results. You can use this version here from Hugging Face, that's the NSFW, that's the non-safe for work. So meaning you can create everything with it. For whatever reasons, my results were better here for my crystals. So let's stick with that one. I put the link into the description. The moment you download it, you put it here into Models Stable Diffusion and Models LoRa. The LoRa comes there. The link is in the PowerShell script, and the whole model, the big one here, that comes here into Models Stable Diffusion. You see a lot of more models specialized to do one thing or the other. So really try it out depending what you want to generate. That's much easier. You see there are a couple of models here that I have trying out, and the results are really dramatically differently. So you really have to look what works for you, also storing the seed that works for you best, what I did here for my crystals. So that apple looks much better. Important is if you go to the creation of the PNG file and the metadata that are stored in there. Here you see the model name, the Juggernaut X Run Diffusion, blah, blah. And you need that as a model for the PowerShell script to put in here. If you add docs between your URL for the local installation, you will find actually the API of Stable Diffusion. And here searching for text to image, you see exactly what we need to get that API working, posting exactly that request body. So the request body is something you will find in the PowerShell script. That is this automate, SD automate PS1. And here that's exactly the request body that was here in the tryout given as an example. So what we essentially do, we adhere us to our standards, we fill in the variables and post that to that API. And the API here, that at the moment is localhost, so the local installation, but it can be really everything. So important is of course my JSON file that will steer my prompts. So that is a file with an array of JSON objects. Doesn't matter what JSON objects there are, they just need to have two properties: name for the file name and picture prompt for the prompt to create it. We will use that prompt and add a more generic prompt on top of that, and that is the prompt that we will use. Here's the output directory that will be created. Here's the model that we use. That's the model name that needs to be here. Here we use a LoRa, so a more fine-graining, smaller model to add more details in it. We also use that. That will also be added to every one of the requests. And you see the models here, the URLs here. The batch size is 0, just one picture really, but you can do as many as you want. The general prompt is a prompt that will be added to each prompt that comes from the JSON file, simply to add some more general instructions to it, like, for example, it should be a crystal, it should have a white background and stuff like that. Same with the negative prompt, a couple of things we don't want. We don't want to use text, for example. It should not be blurry, or depth of field should not be here. I want a sharp picture. Then the seed is important. That is actually something I tried out. It worked best for me. If it's -1, it's random. And skip if file exists will skip if a file exists, meaning you can just delete the files that you don't like, and then next time they will be recreated. Here's the main region. First thing, I just check if the output path exists. Then I load the JSON file, put it in a hash table. Then I iterate over the hash table and create this composed prompt. That is what we got from the JSON file, plus the general prompt, plus the LoRa. Then I generate this request body as variable. You see a couple of things are hard-coded here in the request body. And that is something that you can adjust if you need it, meaning, for example, the width, the height, or something like the scheduler assembler name. That is depending on the model. Most models will comment what they kind of expect, how many steps you should use for optimal results, but these are things that you have to try out really. So Civkey scale, that is how much it actually should listen to your prompt and how inventive it should be to create something new. That's also extremely model dependent. What works best, again, you have to try it out really to get your optimal settings. And with that, we really just do a couple of reportings and we'll store the result into a file that has the file name and then an enumeration if you have more than one. So let's try that out. We are here in our Stable Diffusion directory. I go to the Stable Diffusion automation that I downloaded from Git. If I look at the directory, you see this SD automate ps1. The SD start is just starting Stable Diffusion. That's a minor one. On the moment I really start it, it will load the batch file. It will look at the API and it will start generating the pictures that you need. And if I don't like one, I just delete it and next time it will be recreated. That's it essentially. With that, you can really start creating locally as much as you want. It gets interesting, of course, modifying the prompt a bit more, maybe with random things. That is also quite easy to implement. I think you have a framework now, and I hope you create happily around. You see, this is a bit sped up. It's about 40 seconds here, as I said, from an RTX 360 NVIDIA card. So it's a bit older card, but it takes some while, but it's near to impossible without a dedicated graphic card. Okay, happy modeling and creating, and I hope that helps. See you soon.